Hey, 30-1s. Arc length and coterminal angles. Okay, this will actually be rather easy. So what we're talking about here is arc length. Well, if you had watched the first two videos, especially the one about the history, again, really, the beginning of all of this, it wasn't about triangles, it was about circles, wasn't it? And so they were the Babylonians many, many years ago, or many years ago, many to the power of 10, we're trying to figure out how far this star or this sun had traveled. And so this right here was deemed to be called our arc. And this is our angle. The Greeks came along, right? And they had to butt in and they said, we're going to call that angle theta. So that's usually what we call it. So we want to know how far our star has moved. And that's our radius because we're talking about a circle. So there's a really easy formula that we're going to use here. It's on our formula sheet, A equals theta r. I believe on the formula sheet in 30-1, they have it rearranged to be this. I'm a crazy guy, I prefer it A equals theta r. Now, there's one huge trick I need you to know here. Well, again, just maybe before I do that, that's my arc length. That's my sector angle, how far I've traveled, and this is my radius. Okay, here, amigos, is, I don't know if it's a trick, but I need you to know this because they're going to try to trick you on your test and your diploma. This angle here, please, this has to be in radians, not degrees. Why? Well, look at the formula. It's working with the radius. Radius and degrees don't go hand in hand. Radius and radians go hand in hand. So if it was me, what I would do on my formula sheet is I would actually, beside this formula, go in radians. How are they going to trick me? Or try to trick me? They're not going to trick me because I'm smarter than that. So it's going to say something like this. So very common questions we get here are things about wheels. You're going to see Ferris wheels a lot when you're doing your homework because we all ride Ferris wheels every day. Recently on the diploma, we've seen a carousel. Whatever, you're going to get some application. So in this one, a point on a bicycle wheel spoke has a radius of 30 centimeters and moves through an arc of 270 centimeters. How many degrees has the point moved? To the nearest hole. Okay, I've underlined it right there. That's how the question is trying to fool me, which is unfortunate. I'll show you what I mean. So here's my formula. A equals theta r. Okay, what do I know? Well, I know that it says it has a radius of 30 centimeters. I know the arc that this point on my wheel has traveled is 270 centimeters. And I want to know how far in degrees this point has traveled. Okay, so I'm going to sub these values into my formula. So 270 centimeters is equal to theta times 30 centimeters. Well, I'm happy because first off, I can check my unit analysis. I can see that I'm in centimeters. So they're not trying to fool me there, which, you know, might happen on occasion. So that's something I want you to keep an eye out for. So I'm just going to rewrite this now. I don't need the centimeters anymore. I'm happy that it's the same units. We need to solve for theta. So I'm going to divide both sides by 30. Okay. So this right here, what we have, that's our arc length. But what I want you to think about is that this is theta in radians, right? This is theta in radians. So this would be 90 rads. Whoa. Okay, but the question didn't ask for radians, did it? And also helps if I can do math. That would be 9 rads. So now that I can divide properly, the question didn't ask for degrees. The question asked for radians. That is the usual kind of, I'm going to mess with my student question. So all I need to do now is convert from degrees to radians. Well, 9 radians. Set up my unit analysis here. 180 over 1 pi rad. Radians divide out. And so now all I need to do is plunk this thing into my calculator and see what we get. Well, 9 times 180 is 1620 degrees over pi. Divide by pi. And I've got my approximate symbol there because I do need to approximate this one. This is to the nearest degree, 516 degrees. There it is. So the spot on the tire has traveled 516 degrees. So when you see these questions, I want your spidey senses tingling. They're messing with me. They want the answer in degrees. Guess what? The formula is in radians, right? Radians. So watch for that as you're working through this. Last small concept I want to talk about here is something known as coterminal angles. What does that mean? Well, terminal means I'm ending. Co means is the prefix for share. So what does this mean? Let's go back to our circles. Let's say we traveled 30 degrees. I'll keep it in degrees because we're very used to degrees, aren't we? Let's say that's 30 degrees, not drawn to scale, right? Well, 30 degrees is how far we've traveled right here, isn't it? In the positive direction. We're following the sun. But I know the sun doesn't just go around me once, right? Should try that again. I know we don't go around the sun just once, right? As the earth spins. So what would happen if I did this? Right? The earth spins, hey, the sun comes back up on the horizon, and I stopped in the same spot. Well, how far have I traveled on the blue arc? Well, the blue arc here is 30 degrees, but then I did another full revolution, didn't I? That's 390 degrees. But I'm hoping you see, wait a minute, 30 degrees and 390 degrees end up in the same spot. So this is called coterminal. Terminal is where we ended. Terminate, that's where I ended. Coterminal means I'm sharing the same ending spot. So what does it mean to be coterminal? I'm going to add 360 to my given angle. Or if for some reason we think of the Earth as rotating the other way for a second, look at what we could do. We could go backwards, couldn't we? And we could end up in the same spot. So going backwards, instead of adding 360, I would subtract 360. So there's another coterminal angle. If I want to write a formula for all coterminal angles with 30 degrees, well, I'm just going to make a formula. Coterminal angle. So we call our angles theta. Well, 30 degrees, I'm going to plus 360 degrees. Or I could go 720. Or I could go 1080. Or I could go backwards minus 360. I could go backwards 720. I could go backwards 1080. So I'm going to say we're going to go backwards or forwards some revolution. Let's call that n. So this is our number of revolutions, our number of times we go around. And I'm going to say I could go forward or backwards. So I'm going to say n is a member of the integers. Now, the proper symbol for integers is z, but you may see I Either are, I guess, acceptable, but I would prefer Z. And this is a set, so I'm just going to throw it in set notation, just like that. There it is. There's coterminal angles. What if they gave me a question in radians? Well, no big deal. If I'm in radians, I do the same thing. If I said, what is coterminal with an angle of pi over 6? Well, instead of adding 360, I'm going to add 2 pi because that's a full revolution in radians. If I wanted all coterminal, I'm going to put in n for the number of revolutions, comma, n is a member of the integers. And there's my set notation. So what have we done? We've talked about coterminal angles, meaning we end up in the same spot, and we've talked about arc length. And I'm going to, when I get these questions, make sure they're going to mess with me most of the time. If it gives it to me in degrees, I'm going to have to convert to radians. There it is, my friends. See you next time.